there are three ways to write it. One way would be writing A to B. So that's word form. It's A to B. So you can see it in word form. You can convert it from word form, simplify word form. The second way would be in a typical ratio format, A colon B, which is read A to B. So it's read the same way, just has that colon there. And what's that third way of seeing a ratio that you've seen it so many times before? Fractional form, which is A over B. Every fraction you've ever encountered is a ratio. It's a comparison of the numerator to the denominator. So you've been dealing with fractions, I don't know, what second grade, third grade? You're looking at simple fractions like a pi or a rectangle divided into parts. So ratios have been around for a long time in your education. All right, you have to be able to write in any form a comparison of two numbers, and it says by division. What do they mean by division, Michael?
Like dividing.
Divided, but where's the division going on here? All of them. Where's the division bar? Right here in the fraction. This is a division problem. A divided by B. Therefore, these two are also going to be division problems. Okay, let's look at this class. Let's see. What's the ratio of boys to girls in this classroom right here? And I don't count. So boys or girls?
Is it everyone in the class total? Because we have first semester girls.
Just here right now. Whoever's here.
9 girls. 9 girls.
We had 9 girls.
Well, we should have 9 and 9.
So right now, who's here?
8 and 9 girls.
All right. So how many of you got? Is it 8 boys to 9 girls? Wow, that's a lot more split up than. So 8 to 9 is one way to write it, and that's boys to girls. Write it the other two ways, please. So this is ratio format. So you need to write it in word form and fractional form. So word form would just be 8 to 9, and then fractional format would be 8 to 9. Those are your three formats. The other class, boys to girls, was 7 to 13. So 13 girls in that class, 7 boys. And at the beginning of the day, we only had the girls sitting here. I'm like, where are all the boys? Well, there's only 7 of them, but all 13 girls were here. They were coming in late or they were scattered. Oh yeah, golf was going on too. But yeah, this class has a more even split. So you guys are almost. Actually, with Peter here, right? It'd be a 9 to 9. How would that simplify if Peter were here? It'd be 1 to 1. You would say it's one boy for every 1 girl. Interesting. All right.
We have 18 people and they have 20. How does that make sense? Couldn't they just give us one person?
Well, I think we had, it was 19 to 18, and then we had a new student, I think Molly came in, and they gave it to that group for whatever reason.
They should have given us both.
Yeah, so I think they split it up, and yeah, I don't know.
That's
Yeah, I know, the evenness. Okay, so let me actually go back to another one here. They give me an example on page 280. The ratio of handheld devices, right underneath word form, ratio, and fraction form. The ratio of handheld devices to students is 32 to 48. 32 to 48. What are handheld devices?
calculator.
Ancient technologies.
Calculator.
Devices that hold in your hand.
Yes. And in this case, they're talking specifically about calculators. Write it the other two ways.
I can hold it in my hand.
No, you can't. You don't have to.
I can hold it.
Not here.
You and your
No worse.
Oh, what's worse than that?
Terminated.
You wish you were being taken away. No.
What would just happen is secretly every time we have an Apple Watch, teachers steal it and they disperse it among the teachers, and so all the teachers have Apple Watch.
Yeah.
How'd you know that, John? You know too much. All right, anyway.
I never saw that.
go ahead and realize, okay, they had 32 handheld devices of 40. Timeout. Announcement time. Speaking of handheld devices, Mr. A has finally broken down. It takes him 3/4 of the year to get to this point. Yeah, right. That's never going to happen.
Do we get calculators? Can we have a calculator?
On Wednesday, I'm going to allow you to start using calculators, but listen to me carefully. It's not to the point where you just do everything on the calculator, never show work. You can still show your work like this, and you can still use your calculator at the same time. But the reason I do that is because some of the numbers get into like decimals and more complex fractions. And I want you to show me your steps, but you can do it with calculators starting on Wednesday.
Wait, so
Wait, do we need like those little ones or like the big kid ones?
Say that one more time.
We need like the little calculators or like
Oh, good question.
like ones that you type on. Or like the ones that you have.
Actually, the ones that you're gonna need,
Mine has a ruler on.
they're called, yeah, just so you know which one. They're the ones that have to have, I know this says sin, but it's short for sine, and then cosine and tangent. So they need to have these 3 buttons because, yeah, there's that one. That's a 4-function calculator. This is gonna be scientific calculator or above.
Where do you find those? On the Staples.
Yes, those are the staples.
So like,
they're like $100.
Let's say we need that fraction is divisible by 4 over 4. So we could go divided by 4 over 4.
I just get a Chromebook every time I come
Can
home.
I just
Because I don't want to buy a $100 calculator.
No. So listen to me carefully how I want you guys to do it. Look, so it's one step above this calculator, which you don't have to get by Wednesday, because I'm going to get some myself so you guys can share, but I'm only getting 10. So in this class, 8 of you would need to have it so that everyone has a one.
one.
with your own money is a lot of money.
No.
Schools. It's like $100 for like the calculator.
Yeah, and so that's a graphing calculator, so those big clunky calculators that you will need in high school, but you don't have to get them now.
Yeah,
That's
no,
later.
but then if the calculator is the one that you need us to get is like $20, then we might as well get the
It's like $9, $10, yeah. Wyatt, I need to talk to you after class. All right, so what you could do here is you could get your calculator, and it could be by Wednesday. If you don't have it, like you just can't go to the store, you will be able to get one next week, and I'll have one available for you. So
When do you think
don't worry
we'll
about
need
that.
it? Like, I'll be hard math, like hard math. Yeah.
Thinking, loading. Nope, can't find it. No, you will need it. Just probably next year, definitely next year. Well, time out. Even next year you didn't technically need it, but they're gonna make you use it. Okay, make you use it, which is sad. Anyway, do you guys notice that this fraction is not in simplest terms? That means it's not as simple as can be. So I think one of you brought up, what if I divide this by 4 over 4? Well, my idea is if I want to write this fraction in simplest form, I divide by the GCF of these two numbers. What's the GCF of these two? 16 is the GCF. Does 2 fit into both of them? Yes. Does 4 fit into both? 8, 16. Which one of those is the biggest number, though? 16. So I divide this by 16 over 16, and I get 2 over 3. 2 to 3. That's my final simplification of that. We call that a ratio in simplest form. If that's simplest form for this ratio, how would I write it for this ratio? 2 to 3. You're right, 2 to 3. And then for this way, 2 to 3. So you can simplify any one of those ratios because they have the same terms, and that's how you simplify those. So always write them in simplest form, especially since I'll tell you that in the directions. Sir. Yes, sir? Why?
Do we have to show us dividing by the GCF every single time, or can we just simplify?
Yeah, just do it by the GCF. Just show that, and get that answer. And you could do the actual division in your head, like that, divided by that, but just show me so I know you know what the GCF is. Okay. Now what I want you guys to do is if you go to page 283, I want you guys to do numbers 1 through 3. So 1, 2, and 3, where it gives you on the try these. Write each ratio in fractional form and express in simplest form. So you need to write it as a fraction in simplest form is what it's asking for.
5Fs. Oh, that's not good grades.
Yeah, it's funny, the commentary on these grades. Look what it says. Look at the problem. The chapter 10 test. Uh-oh. 6 A's,
5 F's.
8 B's, 10 C's, 3 D's, and 5 F's.
That's literally what I was saying. It's gonna be pretty close.
I didn't say it, they said it. They printed it out. Now, some of you are kind of worried, like, would I fall in that category? Oh, I hope I'm in that one. The thing is, this is a good spread of scores. That is not unreasonable.
5 F's.
It's a good spread. That's what happens. In a group of, and you'll figure out the total. If in a group that size, 5 F's is gonna happen sometimes. And if it doesn't happen, that means the class is maybe a bit easy,
Wait,
or it's just graded easy.
No, it just means people are smart.
Smart. Why can't people just-
That's possible. That's
People in
possible.
our class got an F on one test before.
No, we don't have that many students.
6th grade, that fast.
But still, 5 people.
I have a
No, that
question.
was like 10 people on there.
The first one, A's to D's. It's 6/3 or 6 to 3.
Sorry. So how many A's? 6 and then 3. Yep. So you write 6 to 3.
2.
Okay, good question. So you get this as fractional form. To say it in simplified fractional form, you say 2 to 1. So put 2 to 1. You divide by 2, divide by 2 to get that. And yeah, leave it as a ratio. So that means I got to put it fractional form. And some of you already know, wait, Mr. A, I thought that equals 2. It does, but we write it in as a ratio in fractional form, so I have to write it like this.
Wait, what did you have to divide by 3?
Oh, yes, ma'am. I got ahead of myself. Thank you, Murphy. Yes, by 3 over 3, which, and I forgot to say on the last one, when I divide by 3 over 3, what did I actually divide by? 1. So did I change the value of 6 over 3? No, I just changed the way it looks. It's in a form, different form. But looking at this right here, do you guys remember your slope? Do you guys remember slope?
Yes.
Okay, do you remember that it was a fraction, rise over run? And sometimes your slope was 2, and you're like, well, what's your rise over your run if it's just a whole number? Well, how would you write it or think of it? 2 over 1. Oh, that's rise and that's run. That's a ratio. Okay, number 2. D's and F's, Davis, to A's, B's, and C's. So how many D's and F's?
Oh, so you don't want to reduce correctly?
Not yet. Yeah, just give me how many D's and F's. D's and F's would be 8 over 24. But then I write in simplest form, so what's the GCF? Yes, 8, and then you get 1/3, or 1 to 3. Yeah, so it's D's and F's to A's, B's, and C's. So 1/3 of the students got a D or an F. That's 1/3 of the students. Which would calculate here 6 of you would have gotten D's or F's.
That's probably accurate.
No, just for this class, out of 18 kids. All right, number 3 though, this one, I got a unique answer in the last class, but I think you guys will get it. A's to all the other grades. Rachel, what'd you get for A's to all the other grades? How many A's?
6.
How many all other grades? Okay, and that is not in simplest form, so what's the GCF?
3 every 33 units.
That's the simplest fraction, but what's the GCF of 6 and 26 to get to that? 2, good. So if you divide both of these by 2, oh, look at that. Then you'll get 3/13. So 3/13 of the students got A's. So that's valid. And don't be scared if in your future that happens. Only 3 students out of 13 students get an A on tests. That's not unreasonable. So here's a little fact of life. You ready? I know it's scary, but it's true. Does everyone get an A?
Yes.
No, it's okay.
We can be in
No, see, here's the thing. It's sad. Everyone in communism gets an F. That's the sad part. It seems like C, but it's actually not, because what happens, and you guys know
That's
this.
not true, they average it out, so you give the
Yeah,
A's.
that's
So you do A
idealistically.
and F, what
but-
you get C.
Look at look at how it's done. Like when it was done in the USSR, everyone was equal for the common folk, and then all the leaders were up here. They got A pluses, and then all these guys got Fs because they're waiting in line for food. No. You want to tell them they got average?
Yeah, I do.
No, you don't want to tell them that because they lived it out. Yeah, that was a poor average if they got it. Really, I'm saying that because that's how practically it works. People don't get a good, like, it's kind of okay. No, you get poor grades, poor service, poor lifestyle, because that's not how things work, unfortunately, for them in our world.
Is this all of the
No. Proportion. A proportion is an equation. So let me tell you this. What does an equation always have in it? Equal sign. So if it doesn't have an equal sign, it can't be an equation. But an equation that's also proportion, here, that shows two ratios that are equal. So I had to change the way I said that with the way I'm writing it. But a proportion is an equation showing two ratios are equal. And you dealt with proportions a lot. And there's one big fact I need to get with proportions. But before I get to that, an example of a proportion would be A to B. Is that a ratio, A to B?
Yes.
Okay. And another ratio, C to D. Is that a ratio? When I put an equal sign between these two ratios, I formed a proportion. And so I'll be honest with you, this lesson, we're not working with proportions, but next lesson and the lessons after, you're going to do a lot of proportions. So this is a proportion. This ratio is equal to that ratio. Have we dealt with that today? Is this ratio equal to this ratio? That's a proportion. So we have dealt with it, but we need to understand the cross products property, because not every time I put an equal sign is that true. Bless you. Okay, so the cross products property, that's a little tough to say. A over B equals C over D. So two ratios equal one another. Do you guys remember that A times D is equal to what? B times C. If A times D is equal to B times C, this is a true proportion. So there are false proportions and there are true proportions. Is that true in life?
Yes.
I was telling the 7th graders, I think I told you guys last year, for example, and this is older technology, but it happened, it's cool. But like movies used to use proportions, and I would say all movies still use proportions, but like Jurassic Park, you guys remember that movie?
Yeah.
The first one, not the new Jurassic Parks, but the first one. I mean, when I was watching as a kid, I'm like, whoa, that's so cool. That's like a big giant dinosaur just scrunching up a car like nothing. And do you know how it actually was filmed?
Yes.
They had a toy.
It's like it's a big table, and I say big, it's like this big. And they have these model dinosaurs, and they zoom in on the camera, and their effects are going to show this dinosaur like chomping on a car, like a Matchbox or a Hot Wheels car. That's so scary. Well, they used what? Proportions to do that. Now, are all proportions realistic or real or true? And they're not. And here's a phrase we commonly use. I'm going to blow it out of proportion. That means I'm not showing the equal ratios. I'm going too far on one side.
Mr. A.
So are all proportions true? No. How do you know if they're true or not? The cross products property. If these two multiply together equal these two, it's a true proportion. Okay, let me give you an example. Did I have a hand here? I thought I heard something. Okay, let's go with 1/2 equaling 27/54. So I need to determine if that's a true proportion, and I do it by using the cross products property. So what's 1 times 54, and what's 2 times 27? So I get 54 right here equals 54. These products equal one another. That means that was a true proportion. So that's how we do check on ratios equaling one another. Make sense? We're going to use that later. That's not today, but I'm going to introduce it because I want to review it next time. It's still true negative numbers if the value of this is equal to the value of that. Sorry. If this is a negative and that's a negative, and you could check it if not, because if these were both negative and that's negative, that wouldn't be true. It can't work. But you can check it with cross products rule. Good question. Yes, sir. What a great question. Maybe the question should be, have we graph proportions? What a great one, Davis. I'm glad you brought that up. Page 281. I'm just going to look at them, Davis, to see if we've ever done any of these. Have we graph proportions? Absolutely, yes. Anytime you've used slope-intercept form, do you guys remember y equals mx plus b? I know, it was tough, but do you guys remember using that? That's using a proportion. You're like, wait, how does that work? Real quick, if the ratio, or excuse me, if the slope was, let's just go with 2 to 3, and the y-intercept, so let's just review real quick, is just 2. 1, 2, 3. Okay, real quick. We started off with 2 on the y-intercept, and then do we go up 2 over 3?
Yes.
All right, right there. Or you can go down 2 over 3, and you get this line. But what happens if you went from this point and you went up 4 over 6? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Oh, sorry, I counted that. 1, 5, 6. There you go. It comes out the same thing. So you use proportions. Does that kind of make some sense?
Yes.
Now, I'm not going to require you to know this, but there's something they bring up which is really deep. Really deep, but I think it's really cool. Called the constant of proportionality. Let me say that again. The constant of proportionality. You're like, what are you calling me? The constant of proportionality. You know what that is, guys? What's that? That's the slope. That's the slope of a line. Is a constant of proportionality. That's all it is. Nothing too deep there. All right. Let's move on. Unit rate. Write this definition. This is the last thing we're talking about this morning. What is a unit rate?
My rate.
The rate of the unit.
A ratio comparing two different quantities and the denominator equaling one. And I think that's awkwardly said. A ratio comparing two different quantities and having a denominator equal 1. I had to change the way I wrote it because I think it was a little bit weird the first time, and then it was weird the second time, but third time's the charm. Davis? Awesome.
Is our test going to be on quarter 3 or
Quarter 3, which ends on Friday. This Friday, quarter 3 will end. And there are no more assessments in my class for that. So,
Oh, wait, never mind. Sorry. We're having another test.
is it Monday?
Yes.
Did we have a time change?
Yes.
Oh.
When do you think our test will be ready?
As soon as I can. Really, I'm trying. Sorry? Do you what? The time? Yes, last time. Oh, man, we botched that one. This time I woke up, and then I was like, oh, man, it's already time.
Oh yeah, you came to church early.
Yeah, we were totally early. Like, why is everyone late? And now we were, yeah. Was it funny? Who said it was funny? Who said hilarious?
Bad kid.
You think I was laughing?
Yeah.
No. We were actually. It's a good job. Okay, sorry. A unit rate. is going to be a ratio comparing two different quantities. So you're talking about two different units, and then the denominator has to equal 1. That's the key to the unit rate. Okay, so 200 miles in 4 hours. Man, that's quick. But if I compare it using a unit rate, it makes more sense, and I'm like, okay, now I know what that's talking about.
If you always use unit rate, it might just be like a fraction over 1 or...
In fact, we use unit rates so much that we convert to unit rates all the time. So we're going to say, well, 200 miles in 4 hours, isn't that simply 50 miles per 1 hour? What did you divide both these numbers by? 4. Yes, over 4, which gives me 50 miles over 1 hour. So is this a unit rate? Is it a ratio comparing two different quantities with a denominator equaling 1? Yeah, so it's a unit rate. And we compare things unit rate. Wow, but I went 900 miles in 11 hours. Translation, please. You convert it into a unit rate, and then you're comparing like things to one another. So 50 miles per hour. Another way to get a unit rate from a fraction or a ratio is just to do 200, the top number, divided by the bottom number, which gives me 50. Now, sometimes this is easy. It's an easy number. And sometimes this is easy. So do you think you're going to use only one today?
Yes, probably.
I hope not, because, like I said, they get a little bit tougher. Go to page 283, and I want you to get the unit rate for number 4 on the try these. Number 4. 256 miles on 8 gallons of gas. That's amazing. But what does that actually mean? So we're going to figure that out, hopefully, by getting a unit rate. So 2 ways to do it. Some of you are just going to divide both by 8 over 8, which gives me something amount of miles over 1 gallon. And then some of you are going to do 256 divided by 8 just like that, and you'll get an answer.
But if you don't know, you're going to still have to do 256 divided by 8.
Yeah.
Exactly. And yeah, some of them are clear, like if it were 2 over 2, you just divide them in half. Or you divide it into halves, and then here you can just divide into your regular problem.
Do we have to write miles and gallons?
Yes, you must write the units. Must write the units. So what'd you guys get? How many miles per gallon?
32.
32 miles per 1 gallon. And what do you think about that?
Average. That's pretty good.
I think it's pretty good. My van, it gets 24 miles per gallon because it's a big van.
Is it a white van?
Michael!
Why, did you see me driving a white van?
I love white
Sorry?
Crash your car.
That car got 29 miles per gallon, but no more. Gets 0 miles per 0 gallons.
And free Wi-Fi.
But yeah, we got a van because of the kids, and because now I get to be a soccer dad. And literally, I am a soccer dad. I will take my sons to play soccer. Okay. But anyway, 32 miles per gallon is pretty good. Unless it's like an electric vehicle, which should be getting more than that. If this is a truck, that's pretty good. Like, that's a very good efficiency truck. It just depends on the vehicle. Okay. Next one is your homework. Oh, my.
Wait, we have another class this afternoon. We're gonna learn more.
Got it.
No, we don't.
We're gonna do our homework this afternoon.